Hey everyone, this is Greg. How are you this evening? It is our week 5-6 transition video, and it's a beautiful day in Oregon. Boy, we've had some hot weather, and they're saying this week we're going to hit in the hundreds, and that rarely happens around here. So on one note, I'll be traveling a little this weekend, this week, and I will be online as much as I can. Always contact me by phone. I'd love to talk to you and help you with anything. And if there's any question before you submit any of the assignments, please let me know. Now, this week there are 3 assignments, and they're all different. One is the independent samples t-test, and one is the dependent samples t-test. The independent and dependent samples t-test are different. So we're going to start with the first one. Now, the last assignment is the ANOVA, and I will give you very precise guidance on how to complete these assignments. So during a day or two ago, I sent you out in an announcement an example of how to do a 2 independent sample t-test. Now here's what a 2 independent sample t-test is. Let's say I believe that I have a null hypothesis that the mean score of 8th graders in one county is the same as the mean score of 8th graders in another county. And the only way I can do that is to pull a sample from each. Now my null hypothesis is that those means are equal. The population means are equal. Well, from the 2 samples, I can get different sample means. One might be statistically significant, one may not. Now, here's what the 2 independent sample t-test tells you. When you put the 2 samples in, and I've sent you some screenshots on how to do that, if the result is statistically significant, that means the p-value, or SBS calls it significance, but it's actually the p-value, which is the probability of making a type 1 error, which is rejecting the null hypothesis when it is true. If the p-value result of the test is not less than 0.05, then we can't reject the null hypothesis. So that means that even though the sample means are equal, the population means may still be. So just because 2 sample means are different doesn't mean the population means are. They have to be statistically significant, and that means that it's likely that the population means are not the same. That's what's called a statistically significant result of a hypothesis test. And some of you had some really good explanations of statistical significance, but we're getting there. Trust me, a lot of people spend years trying to get some of these concepts down, but it's at the heart of research. So, when you do your 2 sample t-test, here's what I would like to see you do. I know the content requires you to copy and paste the SPSS output in the assignment. Please don't do that. It's not necessary. The only thing you have to do is list the values from the 2 samples. And after you've done that, then take from SPSS the results of the test. So there's only 3 things that have to be reported. The degrees of freedom, which is always the sum of the 2 samples minus 2, the t-value, and the p-value. Now, the p-value in SPSS is called significance. So when you run that 2 samples t-test, it'll say sig. Well, that sig is your p-value. And then, if the properties of your samples are such that the p-value is less than 0.05, then you can reject the null hypothesis that the population means are equal in favor of the alternative, which is that they're not. Another good resource is to look at the example final project I sent and look how those t-tests are written up. So, please don't copy in the SPSS output. It's important to learn how to format the results of the t-test according to APA. And the way you do it is it's always put in here as T. This is your degrees of freedom. This is your t-value, and this is your p-value. Okay? And remember, your p-value is your significance in SPSS. So, take your time on these. Just be very careful, and we'll have a good week. Now, Thursday is what is called a dependent samples t-test, and that's entirely different. Here's what a dependent samples t-test is. Let's say you have 10 people that go to a training program, and they're given a test on safety or something. And then they spend 3 days in the program, and then the same 10 people are given another test. The dependent samples t-test looks to see if there's a statistically significant change for the same 10 people over time. Now, the independent samples t-test does not do that. It pulls samples from 2 different groups and compares them. This is a common mistake, when to use the independent and dependent samples t-test. The book's a little unclear on when to use the dependent samples t-test. I'm going to put out some more information on that to guide you a little. Finally, on Saturday is what is called an ANOVA test. Now, an ANOVA is equivalent to 2 independent samples t-test, but it compares 3 populations. So, whereas in the independent samples t-test, your null hypothesis is that the mean of population 1 is equal to the mean of population 2. In an ANOVA, it's the mean of population 1 is equal to the mean of population 2 is equal to the mean of population 3 or more. So it compares several means. And I'm going to give you some guidance on how to report ANOVA correctly and what it tells you. So it's getting technically complicated, but I really appreciate how hard people are grasping with this. And you will get it. So start with the independent samples t-test, and please look at my example in the announcements on specifically how to report the results of the test. There's other tools that are very simple. You can Google tools on how to use an independent. There's a bunch of calculators out there on how to do independent samples t-test, dependent samples t-test, ANOVA. But we do require that you learn how to use SPSS. So that's what our week looks like. Now, so far, things have been going very well. Let's look at how we're going to move towards the end here. This is week 6. There's 3 statistical tests you'll talk about. Independent and dependent samples t-test and ANOVA. Week 7, we talk about correlation. Okay? Week 7, we talk about correlation. Then week 8 is devoted towards the final project. And what we will do is I will be back by the end of week 6, and I'll be back in the middle of week 7. But what we will begin to do is set up times where we can talk about your final project, because honestly, the final project is the most challenging part for people. So I encourage you to look at the examples and start to think about what your project is going to look like, what your research questions are, what your hypotheses are. And so we can have some good conversations on how yours is going to roll out. So we're doing pretty well. I appreciate your hard work. Don't hesitate to Google these things, to study them, to look in statistics books. It's all universal knowledge. And it's important knowledge. So things like statistically significant, the p-value, which is the probability of a type 1 error, the alpha, which is usually set to 0.05, which is the maximum allowable type 1 error set by the researcher, the t-value, degrees of freedom. All these things are very important. So thank you for your hard work, and I will be sending out some screenshots on how to do the independent samples t-test tonight. And I hope wherever you are, it's a little cooler than Oregon, but I never complain about the heat. We have long winters. Okay, everybody have just a great evening, and thank you for your hard work, and have a good week.